class again. Today we start a new subtopic of mathematics, that means subtopics of derivatives of different kinds of function. Particularly in this video we discuss mainly derivatives of parametric function. Before starting, firstly I want to define what do you mean by parametric function. Thereafter again I will go towards different kinds of problems. First of all, you have to understand what do you mean by parametric function. What do you mean by parametric function? What do you mean by parametric function? Parametric function, 1 second wait. Sorry. Parametric function means that what? Firstly, see here. Parametric function. As you know that in the previous class I have studied about derivative of implicit function, in which we differentiate, that means given equation we differentiate on both sides and we separate or common from arranging all terms in a particular order, and finally we find dy dx. But in this particular function, totally we are going to different way to find dy dx, that means derivative of a function. Parametric function, what is this function here? Suppose that there are two variables x and y. Suppose that there are two variables x and y, and it is function of another variable, that means third variable. X and y are two variables which is depends on other third variable. In that case, suppose that x depends upon t, that means x is function of t and y is function of t. That means suppose that I want to take another function like 5t square plus 5t and y is equal to e to the power t, e to the power t. Definitely you will tell me here, sir, x is a function of t as well as y is also function of t. In that case, how can you find that value of dy dx? While two variables, it depends upon third variable, or in other words you can say that if two dependent variable which function of third independent variable, as you know that here x and y are both treated as a dependent variable. Firstly, x depends upon t and y depends upon t also. In that case, x and y are treated as dependent variable while t is the independent variable. In that case, here you will tell me, sir, x is a function of t and similar way y is also function of t. In that case, in order to find the value of dy dx, that means derivative of y with respect to x, you have to find firstly dy dt and thereafter you have to find dx dt. You have to find dy dt, again you have to find dx dt, and if again after finding dy dt and dx dt, if you find again derivative of y with respect to t, whole derivative of this function, that means with dx dt, if you take as it, definitely it will give you a dy dx. Now you will tell me, sir, as you know that this is not as a treated as a numerator and denominator. In that case, how can you remove dt and finally you will get dy dx? There is simple concept. While you express dy dt in limit forms, in that case automatically dt cancel and finally you will get dy dx. That means whenever you will face this kinds of problem, that means there are two variables which is expressed in third variable form, firstly find in this problem x is function of t, that's why you have to find firstly dx dt, and here y is function of t, then again you have to find dy dt, and you have to find dy dx. That's why firstly write here dy dt by dx dt, which gives you actual value of dy dx. This is the concept through which you can proceed to solve these kinds of problems. I think you understand very well. Again, I want to tell you again, parametric function means that when two variable is expressed in third variable, not here restricted only to variable. When you are going to in higher class, you will get different kinds of, that means there are many variables, there are many dependent variables, particularly in 3D topics, which is expressed in third variable. In that case, that third variable will be independent for all three dependent variable. But here there is only two variable, x and y, which depends upon t. So x is the function of t as well as y is also function of t, and from it you can find dy dx so easily. First we find dy dt, again find dx dt, and take as a usual way a ratio of it, and finally you will get dy dx. This is a usual way through which you can find easily dy dx. That means derivative of that function with respect to x. Now I think you understand very well. Again I want to repeat it. The parametric function means when two variable is expressed in third variable form, or two variable function of third variable. In that case you will tell me, sir, that function or that given function will be parametric function. Now I think its concept has given already here. Still I want to give, suppose that the x is the function of t and y is also function of t. In that case, don't take here. Take here x is function of t, that means phi, and y is function of here I want to take phi 1 t. In that case, firstly find dy dt, and thereafter take dx dt and find its ratio, and finally you will get dy dx. This is its concept. That means in whole chapter there are two variables which is in expressed in third variables will be given, and you have to only find a derivative of y with respect to third variable, again derivative of with respect to third variable, and after taking its ratio you will get dy dx simply. Now I want to solve some standard problems which is relevant to this concept. See here. Before starting, I want to tell you how can you solve solution method. Solution, you can tell me particularly parametric function. Parametric function related the derivative of y with respect to x, that means derivative of function with respect to x. There are two ways through which you can find derivative of y with respect to x. Derivative of y with respect to x. Now you will tell me, sir, how can you find derivative of y with respect to x in simple way? First of all, suppose that x is a function of t, phi t, and y is a function of I want to write here x is function of t and y is a function of t. In that case, if you want to find the value of dy dx, there are two methods. First method, and here I will discuss second method. What is first method? First method is very simple method. In order to find the value of dy dx, firstly find dy dt, again dx dt. Finally it will give after manipulating it dy dx. This is your first method, and this is a simple method. And second method is very smart way. This is a smart method, and how can you solve by this method? I will suggest you. But in general, some problem can be solved very easily by this method, and sometimes it will be very lengthy. So do not use this method always. Whenever you will face after using this method becomes very helpful, then you can use. Otherwise, if you see given problem is more complicated and using this method will be more complicated, do not use. I want to give firstly concept of this method. What is logic behind this method? As you know that in earlier classes I have discussed about derivative of implicit function. I think you understand very well, and if you couldn't understand or not attend your class relevant to derivative of implicit function, first of all see that video, thereafter you will go in this class, because in next class again it will be helpful for you. So I will again tell you, firstly see earlier class, thereafter you can attend this class or after this class. smart method, that means this is second method. In this second method, how can you proceed to find dy dx, that means the derivative of f, derivative of y with respect to x? There is very simple method. In this concept, there is a single goal, there is single aim to find a dy dx. What is that goal? You have to eliminate, you have to right here, we have to eliminate t by manipulating x and y algebraically. Means that you have to remove t, eliminate t algebraically, and get relation between x and y. In a smart method, there is a single aim. You have to find relation between x and y algebraically, and that means you have to find a relation between x and y algebraically such that t is eliminated. Now, firstly, I want to take some simple example. Suppose that I want to take x is equal to sin theta and y is equal to cos theta, and you have to find dy dx. You have to find dy dx. Then you will definitely tell me, sir, firstly find, as you know that x and y are two dependent variable which depends upon theta, which is a third variable. Now here x is sin theta and y is cos theta. Using this method, first of all you have to find dy d theta because it depends upon theta. That's why you have to find dy d theta. In second case, you have to find here dx d theta, and in order to find dy dx, take its ratio as a ratio, but it is not actual ratio, but you have to take as a ratio dy d theta upon dx d theta, and finally you will get dy dx. This is a usual way or general method. But this is a smart method. This is not a smart method. By my side, I take its name. Otherwise, nothing. This is a smart method. But according to this method, you can solve also this problem very easily. Now, how can you proceed? I have told you, you have to eliminate third variable. Now, what is third variable here? Here, third variable is theta. How can you manipulate this equation? Given parametric, how can you manipulate such that theta can be eliminated? Now, I want to give you some hint. Suppose that this is equation first and this is equation second. Squaring equation first and squaring equation second. If you square equation second, you will get x square is equal to sin square theta. And again, if you square equation second, you will get y square is equal to cos square theta. And if you add LHS towards LHS and RHS towards RHS, you will definitely get in LHS x square plus y square is equal to sin square theta plus cos square theta, which is equal to 1. So, in this from this conclusion, you will get what? X square plus y square is equal to 1. If you see in this given condition, that means in given parametric functions, you will see here x is a function of theta, y is a function of also theta. As in this given problem, x is equal to sin theta and y is equal to cos theta. According to this method, I have already told you, you have to eliminate theta such that there exists relation between x and y, such that there exists relation between x and y, algebraically such that theta does not present here. Here, by manipulating, you get a relation between x and y in such that x, y, and there is some constant. Otherwise, there is no theta. Always try to manipulate given both equation as such way such that you can express both dependent variable in such a way only there should be its expression constant and action while otherwise there should be no any constant, that means sorry, there should be no any variable as which has used in this quotient theta. I think you understand. Now simply by implicit function concept you can find here dy dx. Now simple way you have to write here differentiating on both sides with respect to theta. If you differentiate on both sides with respect to theta, definitely you will tell me sir there should be dx square plus d or dx, and there should be dy square with respect to x, there should be d1 with respect to x. Again I want to write here this step. Derivative of x square with respect to x will be 2x. Derivative of y square with respect to x could not able to find. Firstly, you have to find derivative of y square with respect to y. Again, derivative of y with respect to 1. No, derivative of y with respect to x, and derivative of 1 which is constant with respect to x always will be 0. Always will be 0. I think you understand very well. Now, if you see here, there will be 2x plus 2y into dy dx. As you know that you have to find only dy dx. Don't bother by taking it 2x plus 2y dy dx barabar 0. That implies that 2x that means 2y dy dx. 2y dy dx is equal to minus 2x after cancelling 2 on both sides, so you will get finally dy dx is equal to minus x by y. This is the method which is called as mathematics, that means by eliminating third variable. You can tell me by eliminating third variable. This is very standard method, alternative method through which you can find dy dx. I think you understand very well, and this is your general method. You can also find using this method. You can also find using this method dy dx. I think you understand very well. Now I want to take some examples and some problems will be solved, but I will suggest you try to solve most of the problems by first method, that is general method. And when you get some expression is given some different way such that you can eliminate theta or t, that means third variable, you can proceed by a mathematics, that means alternative method. Otherwise always try to go general method. That will be very helpful, and this is very simple method. Do not bother, that means if you solve by that method it will be very helpful for you, and do not bother during solving that problems. Now see next question. Next question will be exercise. Firstly take very simple problem 27. In this question given that x is equal to at square and y is equal to 2at, and you have to find dy dx. You have to find dy dx. How can you find dy dx? As you know that this function is a parametric function. This function is a parametric function. I will suggest to solve this question by two methods. So first method, that will be general method, in which I have already told you. If you see in this question, x and y is both function of t, that means x is also expressed in terms of t and y is also expressed in terms of t. Now here you have to find dy dx. How can you proceed? What are the ways through which you can find dy dx? First will be you have to find here y is equal to 2at. So using general method you have to find dy dt, because y is a function of t. If you differentiate this function with respect to t, definitely you will tell me sir it will be as it. It will be as it. And you know that I have already told you here x and y which are dependent variable and t is independent variable. That's why all three variables always treated as a variable, while I have already told you many times other than these three variables always a, b, c, if there will be any terms always treated as a constant. So 2a can be taken out of the derivative term and dt. Finally you will get 2a, because derivative of t with respect to t will be always 1. Using formula, derivative of x to the power n with respect to x will be n times x to the power n minus 1. And this is your first term. And in second way part, you have to, as you get x is equal to at square, firstly you have to find here dx dt, where you have to firstly take a out of derivative terms because it is a constant, and finally you will get a times derivative of t square with respect to t. Here you will get a times 2t, finally you will get 2 times at. This is your equation first and this is equation second. This is equation first and this is equation second. Now, as you know that you have to find dy dx. That will be dy dx dy dt dx dt. This is be careful by giving this line. This will be lengthest and this will be smaller inside. Dy dx is equal to dy dt dx dt. Now, if you see here, dy dt is equal to what? Dy dt is equal to what? 2a, right here 2a divided by dx dt. What is the value of dx dt? Dx dt is equal to 2a cancel. Finally, you will get to 1 upon t, which is your required answer of this question. I think you understand very well. Now, this is your general method. That will be first method. Now, I want to solve this question by second method. That means alternative method. How can you solve this question second method? That means alternative method. See here again. Second method is also very easy for this question. Why? Because I have already told you. You have to eliminate third variable. What is here third variable? T, not a. There is third variable t. A is a constant. So you have to eliminate t here from both given expression. Now, I want to firstly eliminate t from equation first. If you eliminate t from equation second, this is equation second, this is equation first. Since we can write y is equal to 2at, so t is equal to y upon 2a. T is equal to y upon 2a. Now, if you put t is equal to y upon 2a in this equation first, so as you know that x is equal to t square, which will be a times. In place of t, you have to put y upon 2a whole square. Y upon 2a whole square. Now, you have to simply manipulate. After calculating in numerator side, you will get y square. While in denominator, you will get 4a. There is no 4a because there should be 4a square and 1a cancel each other. Finally, you will get in denominator y square upon 4a. So, you get here x is equal to y square upon 4a. X is equal to y square upon 4a. If you wish, you can express as it y square is equal to 4a x. Y square is equal to 4a x. Now you have to differentiate on both sides with respect to x. If you differentiate on both sides x, you will get dy square dx is equal to 4a times dx dx. Why have I taken 4a out of this derivative term? Because 4a is a constant. You can take out of derivative terms. Now, as you know that y square can't be differentiated with respect to x directly. That's why firstly differentiate y square with respect to y. Again differentiate y with respect to x, which will be 4a times derivative of x with respect to x will be 1. So it will be 4a into 1. Now, if you see in LHS, you will get derivative of y square with respect to y will be 2y into dy dx. And I have already told you, be careful about during solving this question because you have to find dy dx. So don't worry by taking a time, I have to find its value. There should be no any constant value. That means dy dx you have to find. So take always LHS side. If there should be also terms in RHS, try to get in LHS. That will be very helpful for you. Now, if you take here dy dx will be 4a divided by 2y. 2, that means 2 times it will be 2a divided by y. 2a divided by y. This is why this is your dy dx. But as you know that y is equal to what? 280. In that case, when you will solve by this method, always you will get the derivative of other dependent variable with respect to other independent variable in terms of each other. Definitely in that case, what will you do? Definitely in that case, in final step, you have to find derivative of that variable which is given already. So I want to, it will be 2a by y is equal to 2a cancel, and finally you will get 1 upon t. This is its answer. I think you understand very well, and will not try to hear this question by you can solve this question as this method, but actually I think here first method will be very helpful for you. Now I want to solve this question by third. That means I want to take next question for you. See here. What is your next question? See here, 28. Example 28. In 28, there is given if x is equal to a into 1 minus t square by 1 plus t square, and y is equal to 2bt divided by 1 plus t square, and you have to find dy dx, and you have to find dy dx. Now, if you see in this question, you can again solve this question by two methods. First method will be general method. As general method, I have already told you here a and b are constant. Why? In general way, I have already told you many times. Other than x, y, and t, because there is t, there is also t. In that case, x and y are both are function of t. In that case, other than x, y, and t, all terms are always treated as a constant. But if you see in this question and in this question, you will get x is a function of t as well as y is also a function of t. As a general method, you can find a derivative of y with respect to x easily. As general method, you can find derivative of y with respect to x as general method. But I will suggest here, you can solve a general method, but I will suggest you some alternative method. Alternative method. Now you will tell me, sir, how do you arise? You can solve this question alternative method. Yeah, this is very easy. Now, if you see this expression 1 minus t square divided by 1 plus 1 minus t square divided by 1 plus t square, 1 plus t square, and this is 2bt divided by 1 plus t square. In which form both are expressed? Can you tell me? This is if suppose that in place of t there will be, suppose that in place of t there will be tan theta. In that case, it will be 1 minus tan square theta divided by 1 plus tan square theta. In that case, it will be what? It will be cos 2 theta. And what is this? It will be 2 tan theta divided by 1 plus tan square theta. That means it will be completely sin 2 theta. And in that case, both expression will be very small inside, and you can easily find its derivative. So I will suggest, if you have done adequate practice in particular inverse trigonometric function topic or trigonometric chapter, as well as all formulas are in your mind, you can easily solve all that problems so quickly. Now, I want to give you alternative method for this question. Put t is equal to tan theta. In that case, x. So, in that case, x will be a times 1 minus tan square theta divided by 1 plus tan square theta. And as you know that it will be a times 1 minus tan square theta divided by 1 plus tan square theta, which will be cos 2 theta. So x is equal to what? A times cos 2 theta, while y is equal to what? While y is equal to what? 2b into take b out 2 tan theta divided by 1 plus tan square theta. In that case, it will be b times sin 2 theta. B times sin 2 theta. I think you understand very well. Now you can find thereafter by general method again. Why? Because when you differentiate dx d theta is equal to a times minus 2. That means minus 2a sin 2 theta. Easily you can find. Similarly, it will be 2b dy d theta will be 2b cos 2 theta. And take it as a ratio, and you will get dy dx. But I will suggest you don't to go by that method. You here, suppose that this is equation first, and this is equation second. And if you square on both sides, I will suggest you don't take equation first. Firstly, find here x by a is equal to cos 2 theta and y by b is equal to sin 2 theta. Now suppose this is equation second and this is equation first. Now squaring equation first, that means right here, squaring equation first and sum up. In that case, LHS will be x square by a square plus y square by b square. y square by b square, which will be 1. Which will be 1. This is your required equation that will be got after eliminating theta and t. This is your required equation. Now you can easily find its derivative. How? Simply differentiate with respect to x. If you differentiate, I want to write directly. If you differentiate, you will get here 2x by a square plus here you will get 2y dy by b square, which is equal to this. I have differentiated directly here. Now simply you can find here, sorry, I forgotten here to write dy dx, and you will get dy dx is equal to 2 cancel, so you will get x by minus x by a square divided by y by b square. That means minus b square by a square into x square by y square, which is equal to dy dx. I think you can see in this question what is given in this question. Nothing. Simply it is expressed some that standard problem, which is particularly in sine and cos form. Again I have eliminated theta by manipulation, and finally you will get dy dx is equal to minus b square upon a square into x square upon y square. I think you understand very well this question again. And you will tell me, sir, you do not get here its answer. If you not get its answer, you can put here x square is equal to this and y square is equal to this, and after manipulating you will get its answer in terms of theta. I think you understand. Now I want to take next question for you. See here, what is your next question? You can leave here also, don't follow. Next question will be 29. See here, 29. X is equal to a times theta minus sin theta, and y is equal to a times 1 minus cos theta. And here you have to find dy dx. How can you find? As you know that given expression is a parametric function, so you can proceed by two methods. First method general, and second will be alternative method or eliminating third variable. As you know that in first method, suppose that I want to solve this problem by second method, but if you are trying to eliminate theta, it becomes more complicated, more lengthy for you. You will again tell me, sir, how do you confirm by looking this question? It will be more complicating by a second method and easier in first method. Only depends upon your practice and what has studied or what has done practice in your previous chapter or its elementary topics as inverse trigonometric function or trigonometric function. That means now I want to solve this question first method. Why? Because you cannot eliminate so easily theta from both equations. Now I want to solve this question by first method. First differentiate x with respect to theta, you will get a times, as I know that a is a constant, that's why I want to take out of it, and the derivative of theta with respect to theta will be 1 minus derivative of sin theta with respect to theta will be cos theta, and derivative of y with respect to theta will be a times, derivative of 1 with respect to theta will be 0, while derivative of cos theta with respect to theta will be minus sin theta, minus times minus sin theta definitely will be plus sin. I think you understand. Now, so as you know that I have already told you, dy dx will be dy d theta dx d theta, which will be a times sin theta upon a times 1 minus cos theta. Here a cancel, and in numerator you will get sin theta, which is also equal to 2 sin theta by 2 into cos theta by 2. If you wish, simplify it, and 1 minus cos theta is equal to 2 cos square, 2 sin square theta by 2, 2 cancel, and sin theta by 2 cancel sin square theta by 2 by sin theta by 2 times, and cos theta by 2 by sin theta by 2 will be cot theta by 2 cot theta by 2. This is your dy dx. This is your dy dx. I think you understand very well. This is your answer of this question. Now again I want to take next question for you. which will be 30. See here again. See here, question 30. Here x is equal to cos inverse 1 upon under root 1 plus t square, under root 1 plus t square, under root 1 plus t square. See here, this is very easy, 1 plus t square, and here y is equal to sin inverse t by under root 1 plus t square, and here you have to find dy dx. In general method you can solve this question. Firstly differentiate dx dt, and firstly differentiate cos inverse this term with respect to, that means cos inverse suppose that this term is p, that means you have to firstly differentiate with respect to p. Again you have to differentiate this term with respect to 1 plus t square, again 1 plus t square with respect to p. Similar as this question and this term also, but it becomes very lengthy as well as more complicated. First of all, you have to simplify it. By which process? By substitution process. Substitution process means that put here t is equal to tan theta. If you put here t is equal to tan theta, you will get x is equal to cos inverse 1 upon under root 1 plus tan square theta, while here you will get sin inverse y is equal to sin inverse tan theta divided by under root 1 plus tan square theta. Now after calculating you will get here cos inverse divided by 1 upon root under 1 plus tan square theta. As you know that sec theta will be root under 1 plus tan square theta. So there can you write here sec theta, and here you will get dy d theta will be y is equal to sin inverse tan theta by what? Sec theta. I think you understand very well. Now cos inverse what? Cos theta, because 1 upon sec theta will be cos theta. Sec theta will be cos theta, and it will be tan theta. Tan theta will be what? Sin theta by cos theta. It will be 1 upon cos theta. Cos cancel. Finally you will get here sin inverse sin theta. So it will be sin inverse sin theta is equal to what? Theta, and it will be also what? Theta. That means here you get x is equal to theta as well as y is equal to also theta. So usually easily you can eliminate theta, because x is equal to theta and y is equal to theta. So you can write directly dy dx. Differentiating on both sides with respect to x, simply you will get dy dx is equal to what? 1. Dy dx will be what? 1. You can see this question how much easily you can solve this question. But whenever you go by first method, general method, it will be more complicated, very lengthy, and sometimes you will definitely got in trouble of its calculation. I think you understand. Now I will take next question again for you. It only depends upon your practice. Totally depends upon practice, and I will suggest you try to look questions in which form it is given. Does it expressed in does it be that means I will tell you will be given expression expressed in some trigonometric standard function. If it will be expressed, definitely try to substitute that terms by prior substituted. Now I will take again next question for you, which will be 31. See here, very interesting question, 31. And this is also in NCERT. See very carefully. Here x is equal to a times cos t plus log tan t by 2 y is equal to a sin t. Firstly, I want to find dy dt because it will be very easy. So it will be d cos t easily. Now I want to find here dx dt. Dx dt is equal to, you have to take a out, and derivative of cos t will be what? Minus sin and plus. derivative of log 10 t by 2. Firstly differentiate log 10 t by 2 with respect to which function? 10 t by 2. Again you have to differentiate 10 t by 2 with respect to which function? T by 2. Finally you have to differentiate t by 2 with respect to t. I think you understand very well. Now it will be 8 times. This is your minus sin t. Log, this is, suppose that this is p. Log p, derivative of log p with respect to p will be 1 upon p. So it will be 1 upon 10 t by 2 into derivative of tan theta. Suppose that t by 2 is equal to theta. It will be tan theta. Derivative of tan theta with respect to theta will be sec square theta. So it will be sec square t by 2. And derivative of t by 2 with respect to t will be what? 1 upon 2. This is your expression. Now, if you express it in a standard form, sin by cos, it will go to in denominator. Definitely you will tell me, sir, it will be a times minus sin t. I want to write directly. Sec square t by 2, that means 1 upon cos square t by 2. And tan t by 2 will be sin t by 2 by cos t by 2. Definitely in denominator you will get, after eliminating some terms, sin t by 2 into cos t by 2 into 2. So 2 sin t by 2 sin t by 2 into cos 2 by 2 will be what? 1 upon sin t. That means using formula. In denominator you will what? We will get 2 sin t by 2 into cos t by 2, which will be what? Sin t. So I have written it. Again, if you express in standard form, in condition you will get minus a times 1 minus sin square t. That means 1 minus sin square t divided by what? Sin t. That means in numerator you will get a times cos square t by sin t. I think you understand very well. Now you have to find what? You have to find dy dx. As you know that dy dx is equal to dy dt, dx dt. Now as you know that dy dt is equal to what? Dy dt is equal to what? A cos t. So I want to write a cos t divided by dx dt. Dx dt is equal to what? A cos square t by sin t. A cos square t by sin t. Right here. A cos square t by sin t. In that case sin t will go in numerator. A cancel, cos t cancels, cos square t by cos t times. Finally you will get sin t by cos t, which will be your. I think again you understand very well. Now this is a very good problem and it is also given in NCERT books. Now I will suggest you next method for you. See next question. Next question, see here. See here next question. 32 first. 32 first. In this question, see here, 1 second wait. See here, it is given x is equal to under root a upon sin inverse t and y is equal to under root a cos inverse t, and you have to find the dy dx. This question can be solved by two ways. First will be, I want to only hint and you will find you have to firstly differentiate x with respect to t. In that case, firstly you will differentiate definitely a sin inverse t with respect to which function? Under root function. So firstly differentiate a in which form? A sin inverse t. Again you have to differentiate a sin inverse t with respect to which function? Sin inverse t. Again you have to differentiate sin inverse t with respect to which function? T. As you know that under root x with respect to x will be 1 upon 2 root x, so it will be 1 upon 2 a sin inverse t, and a is a constant and derivative of a to the power x with respect to x will be what? Will be what? X into log a. What is x? A to the power x. X is equal to, here it is a to the power x, and derivative of a to the power x will be what? A to the power x will be what? A to the power x, that means a to the power x, that means a sin inverse t into log a, so it will be log a, and finally difference derivative of sin inverse t with respect to t will be what? 1 upon root under 1 minus t. Similarly you have to find again derivative of y with respect to t, and you will get some expression, and in order to find dy dx you have to take dy dt upon dx dt and you will get your required answer. But you can see it is very lengthy as well as calculation process more complicated. That's why I want to ignore this method and I will suggest you second method. And what is second method? See here. Simply multiply both equations. Multiply each other. You will tell me, sir, how do you confirm this logics here? You have to multiply both equation or square on both sides. As it, you will definitely tell me, sir, what are the concepts behind it. I will always tell you, don't bother by taking it. Only need you practice. Do practice more and more. Definitely, everything will become. Everything will be clear for you. Now, first of all, simply differentiate, multiply each other. In that case, x times y is equal to a to the power sin inverse t. Sin inverse t into under root a to the power cos inverse t. As you know that it will be under root a to the power something in multiplication and radicand, that means it will be definitely a to the power sin inverse t plus cos inverse t. Why? Because it is in multiplication as well as its base same, so power can be added. Now it will be under root a to the power pi by 2, e to the power pi by 2. Why? Because it is formula of inverse trigonometric formula, inverse trigonometric function. Sin inverse theta plus cos inverse theta will be pi by 2. As you know that it is constant, so you can take as a k. You can take as a k. Now finally you will get here x y is equal to k. Why I have taken? Why have I taken here k is equal to under root a to the power pi by 2? Because all terms are constant. Definitely its value will be some constant. So I have supposed there single term. Now differentiate on both sides with respect to x. You will definitely take y out of derivative term y times dx plus x times dy dx. Using multiplication rule and derivative of k with respect to x. In RHS definitely you will get 0 and in LHS it will be y plus x times dy dx is equal to 0. So dy dx will be, so dy dx is equal to minus y by x. This is your required answer of this question. I think you understand this answer, this question very easily. Now we will take next question for you. See here. This is very easy again. Second, see here, y is equal to e to the power sin inverse x, and z equal to e to the power minus cos inverse x. Now here you have to find what? Here you have to find simply. Here you have to find simply dy dz, because this is y, this is z. You have to find dy dz. Don't bother by taking it, because in place of x it has given z. Now first of all, what has given you? Dy. It has told you have to find dy dx. It has told you have to find dy dx. But it is completely wrong, because according to this question there should be dy dz. According to this question there should be dy dz. How can you find? Suppose that as earlier problem, that means the previous problem, if you multiply both equations, you will get y into z is equal to e to the power sin inverse x minus cos inverse x. But as you know that there is no any formula for sin inverse x minus cos inverse x particular for getting constant in place of this term. That's why do not try to multiply both equations. Sometimes try to your intuition idea and such kind of concept, natural concept, such that that means totally depends upon your practice. Such kind of a manipulating. If you take in place of multiplication division of each other y to the power z, you will definitely get here e to the power sin inverse x divided by e to the power minus cos inverse x. I think you understand. And as you know that it is in division and base is same, so can you write e to the power sin inverse x plus cos inverse x? Why? Because when it will go in, that means as you know that e to the power x by e to the power y will be what? A to the power x minus y if age constant, that means base is same, so power will be subtracted from numerator to denominator. So here power is sin inverse x, and denominator there will be minus cos inverse x. So minus minus plus, so it will be plus cos inverse x. As you know that it will be again e to the power pi by 2. I think you understand very well. Now I will suggest you, as you know that in this question you get what? You get here y is equal to e to the power pi by 2 into z. Y is equal to e to the power pi by 2 into z. Now you have to find dy dz. So differentiate on both sides with respect to z. So dy dz is equal to e to the power pi by 2 is a constant. So don't bother by taking it and differentiate z with respect to z. Finally you will get e to the power pi by 2, which is your required answer of this question. I think you understand whole chapter very easily, and if I see in your question, all problems are very easy, and most of the questions are can solve it by simple method, and some problem you have to manipulate and try to solve that problem by elimination method, that means third variable elimination method. I think today's class period will be enough for you, and in next class I will attend for your next topic, which will be derivative of one function with respect to other function. What is the meaning of it? Its meaning, suppose that this is y and this is z. This is y and this is z, and you have to differentiate. Sometimes suppose that there should be cos inverse x. In that case, you have to find d e to the power sin inverse x d cos inverse x. This is concept. That means differentiate one function with respect to other function. Sometimes you will get single function, that means a simple function. Sometimes you will get more complicated function. And all previous lecture will be very helpful for you in next class, because all concepts will be used in next class. That means derivative of one function with respect to another function. As well as next class, I will discuss derivative of that means derivative of function which is solved by logarithmic concept. Because when I have already told you, when you get a function is given as a multiplication of more than two function, that means 3 or 4 function, or the division of 4 or 5 function, or function is algebraically more complex, that means there is given e to the power something, or cube root something power is minus 7 by 2, as it. If there is given problems is more radical, in that case I will suggest you always try to solve that problem by logarithmic function. That means try to take on both side log, that simplify given function in more simplest form, and will be very helpful for you to find dy dx. Thanks all of you. In next class again I will meet you, in which I will discuss particular topic, derivative of one function with respect to another function. Bye all of you.